So the next topic we're looking at here is probability. But before we start solving any of these question, probability is a game of chance, something that you're not sure of. So they can ask you how possible is that thing supposed to be. Then you can say, okay, it is likely possible. It is, you know, not that possible, or it is so much possible. Okay.
Okay, sir.
So for example, if I say, what is the possibility of the sun shining in the sky in a day? There are two events there. Event one, sun will shine. Event two, sun will not shine. So what I'm requesting for is just one event that sun will shine, right?
Okay, sir.
So with that, we can say probability that sun will shine will be 1 over 2 because the number of required outcome is 1 and the number of outcome, possible events is 2. So probability of an event is the number of required outcomes over number of possible outcome. Probability of an event equal to number of what is required from you, okay?
Okay, sir.
Yeah, what is required from you? That's required outcome, or you call it required event so that you can know what it is. Required event over number of events that are possible. So, number of possible events. For example, if I say there are three balls, three balls in a basket, let's say, or in a carton. This is a carton. There are three balls in a carton, and out of the three balls, two are green and one is blue. So two green balls, okay,
Okay, sir.
and one blue ball. So if I close my eyes and I dip my hand into the carton, what is the probability that I'll pick a green ball? So that will be number of green ball over number of total balls that it is possible for me to pick. Exactly.
Okay, sir.
So this is the blue ball, while these are the green balls. So if I say probability of picking a green ball, so that is the required is 2, which is green, over total that is possible, which is 3. So that means there are higher chances of picking a green than a blue. So if I say what's the probability of picking a blue ball, you know, that would be how many blue balls are there? Only one chance out of the total three chances. Exactly.
Yes, sir.
Okay. So with that, we can use this same method to attempt or approach some of these questions. See, this one says, uh, what is the probability that an integer selected from the set of integers 20, 21 up to 30 is a prime number? So the main thing is that from 20 to 30, how many numbers are there? So let's say this is what we have, this is the bag or wherever. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So all of these numbers, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there are 11 in total. So if I pick any one at random, it's possible to pick any of the 11, right?
Yes, sir.
So probability of picking a prime number now, probability of prime will be how many prime numbers are there over total number. So number of prime, you know, prime figures over total population. Okay.
Yes, sir.
So let us now change the color of the prime numbers to red. 23 is a prime number. How do we know it's a prime number? It means no number can divide it apart from 1 and 23. Then, which other prime number is there? 29 is a prime number. Is that correct?
Yes, sir.
No other number can divide 29. But is there any other prime number there? No, because all of the other numbers have other factors apart from 1 and themselves, okay?
Okay, sir.
Like 20 can be divided by 2, 4, and 5, apart from 1 and 20. 21 can be divided by 3 and 7, apart from 1 and 20. 22 can be divided by 2 and 11, apart from 1 and 22. Then 24 has a lot of factors like 2, 3, 4, 6, and 12. 2, 3, 4, 6, 8, and 12, apart from 1 and 24. So 25 has 5 apart from 1 and 25. So 26 has 2 and 13. 27 has 3 and 9. 28 has 4 and 7 and 14. 2, 4, 7, and 14. Then 29 doesn't have any. So 30 has other factors like 2, 3, 5, 6, and 10. So number of prime is 2. Okay.
Yes, sir.
Total population is, so the answer to this one is 2 over 11. So let us now look at the next one, which is this number 2. Oh, it says a fair die is rolled once. A fair die is rolled once. What's the probability of um, obtaining a number less than 3? Yeah, we know our die is something like a cube, right? Right?
Yes, sir.
So if we have maybe it's this. So we now have this. Let's see. These are the faces. So it has a solid face. This, 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 this. So on the face of our die, there are 6 faces. Then so we can have maybe one ear and the 5 on the other face, like you know. Then at the top also, 6 faces. So the faces, the numbers there are 1, 2, 3, 4, 5, and 6 that it is showing. Okay. So this is our total population, or call it sample space. Is that clear?
Yes, sir.
Sample space. So they are requesting for numbers that are less than 3. So how many of them are less than 3? Only 2 numbers, which is 1 and 2. So the answer to this would be probability of picking number less than 3 will be the total number of figures that are less than 3 divided by the total population, which is 1 over 3. Is this clear?
Yes, sir.
Then the next question, number 3. What is the probability of having an even number in a single toss of a fair die? Okay. see, in a single toss of fair die. If it's still a fair die, it has six faces. That is a normal die. So one, two, three, four, five, and six. How many even numbers? So probability of even number will be how many even numbers are there? Those are three over the total population, which is six, and this will be one over two. Exactly.
Yes, sir.
Good. Then the last question. I think there's something I need to change in that last question. That's why I was a little bit because it's talking about the total sum of seven. You can't have a die and be talking about sum of seven, okay?
Yes, sir.
So you must have a pair. What's the probability that the total sum of seven would appear in a toss of a fair die? That's a pair of dice, okay?
Yes, sir.
So say in toss of a pair of fair dice. So now we will we'll get our sample space, something like this. We need up to six. So one, two, three, four, then five, six. So let's say this is big. So we also need six downward. So one, two, three, three, four, and then five, six. So on the first line, let's see. Can you hear me?
Yes, sir.
Okay. So we have the sample space one, two, three, four, five, six. Okay, I think I need one more column there. So what I can do is to just create one more here for the other side. Then I need this and I need this. So I also have one, two, three, four, five, and I need one more at the bottom. One, two, three, four, five. So I'm gonna need one more line here. Okay. Then cover this, cut up this one, then this one, and finally this place. So I have the sixth one. So for the first die, we have 1 to 6. For the second die, we have 1 to 6. Okay.
Yes, sir.
So if the first die is showing 1, the second die is showing 1 also, that's 1, 1. Then we have 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Then if the first die is showing 1 and the second is showing 1, or they both show this, then 2, 3, 2, 4, 2, 5, 2, 6, then 3. 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then 4, 1, 4, 2, 4, 3, 4, 4. These are sample space, that is the possible outcomes, okay?
Yes, sir.
5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. That's what they call double six. Now, the question says, what's probability that the total sum of 7 will appear? Now, for the total sum of 7, we have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. So 1, 2, 3, 4, 5, 6 outcomes. Okay.
Yes, sir.
So with this we have 1, 2, 3, 4, 5, and 6. So the probability of a sum of 7 will now be number of those sums of 7, which is 6, over total sample space, which is 36. And this is 1 over 6. Is this clear to you?
Yes, sir.
Okay, fine. I'll give you some time to put down these details, okay? Then I'll give you what to try afterwards.